In this video, I am going to show you the concept of p-value. Sometimes the p-value is known as the observed significance level or the sample significance level, these kind of names, okay? So let me go back to our first example. So the first example we were looking at in this question, so I'm not going to redo it again. So here, so the sample z, when we calculate it, it was 1.75. When we use alpha 0.05, our conclusion was the new bulb is better than the old bulb. But if you use alpha equal 0.025, we did not have enough evidence to reject H naught. So because we ended up with two different cutoffs, with this case 0.05, 1.645, with 0.025, 1.96. So please look at your note before, okay? So anyway, so the thing is that depending on this alpha, we are going to reject H naught or not. So the idea of this thing is now, so this is what we did in that example, okay? So the idea of that, if I ask you, so what is the minimum alpha level you need if you want to reject H naught and accept HA, okay? So in other words, what we are saying is if I draw the cutoff right here, there's not enough evidence to reject H naught because this is the rejection region. But if I draw the cutoff here, so then we have enough evidence to reject H naught, okay? So in other words, the p-value is the minimum alpha level required to reject H naught and accept HA. So that's the definition, okay? So the p-value is the minimum alpha level required to reject H naught and accept HA. In other words, you need to set your cutoff right on this value, okay? That's the minimum alpha. So see, if you set your cutoff right on that, you barely have enough evidence to reject H naught and accept HA. Right? So that means this is the, according to this question, this is the p-value, this area. All right? So what we are doing is that we figure out the p-value because this is supposed to follow the z. We know how to figure out this area. So you figure out that. Then after that, we make the conclusion this way. If alpha level is bigger than the p-value, okay, bigger than that p-value, then reject H naught and accept HA, okay? So otherwise, okay, in other words, if alpha is less than this p-value, then there's not enough evidence to reject H naught and accept HA. All right? So because that's the minimum p-value. Because what happens is that if the alpha level is bigger than this shaded area, your cutoff is going to be right here. So that way you are in this setup. Okay? Then you reject H naught and accept HA. So if the alpha level is smaller than that shaded area, your cutoff is going to be right somewhere here. So that way there's not enough evidence to reject H naught. All right? So anyway, so the p-value sometimes is known as the evidence in favor of the null hypothesis. Okay? In favor of the null hypothesis. You remember that the two hypotheses we had, H naught. So in this case, H naught was mu equal 900 and against the HA, mu more than 900 in this example. So this p-value is the evidence in favor of that. If you have a very small p-value, mean you have almost no evidence in favor of that. So that means you are more likely to reject this and accept that. Okay? So in other words, the p-value in general is known as the evidence in favor of the null hypothesis, and the smaller the p-value, more likely you are going to reject H naught and accept HA. Sometimes this p-value, people say that that's a sample evidence in favor of the null hypothesis. So if the p-value is very small, you have almost no evidence in favor of the null hypothesis. So let us revisit all those three examples, our previous three examples, okay? So in the example number one, so this is the null hypothesis, this is the alternative hypothesis, all right? So in this case, the sample z was 1.7. So I want to now figure out the p-value. All you have to do is that set your cutoff right on that value and figure out the shaded area, all right? So the p-value from the z-table, because this is going to follow the z-table, the probability is z more than 1.7, which is going to be 0.0446. This is coming out of your z-table. So now that is the answer for part C, okay? So in other words, the answer for this one, find the p-value. Either that or the observed significance level for the test in part A, right there, okay? So part D, state your conclusion using the p-value. Give your conclusion, give your decision using the p-value, okay? So the part D goes like this way now. So if the given alpha level is bigger than 0.0446, then reject H0 and accept HA, means that the new bulb is better than the old. Otherwise, there's not enough sample evidence to reject H0 and accept HA. So this way, you don't have to make a decision for someone else. You are the guy who is analyzing the data. You tell your boss, hey, this is what will happen. This is the sample evidence. If this is the case, if you want to use this big type 1 error, go ahead and reject H0 and accept HA. Otherwise, there's not enough evidence to reject H0 and accept HA. Okay? This is the type 1 error, by the way. Okay? So if you are willing to take a bigger error, in other words, if you are willing to take a bigger risk, then you are going to make a change. Okay? So change and accept that, but that comes with that risk. There's a chance that this much of error. All right. So the second example. So this one, the pain reliever example. So here, this was the rejection region was on the other side, by the way, the lower side. Okay, right there. This is the sample Z. So rejection, this alternative hypothesis less than that. So this. So what you are doing is that to figure out the p-value, you set your cutoff right on there. But here the point is that you have one rejection region on to the left side. All right. So if this is very, very small, you are going to reject H0 anyway. So that's the idea. Okay. Rejection region has to be to the left. So you set your cutoff right on that value. This is the Z. Figure out that shaded area from the Z table. That is that. So when you go to the part C, okay, so this is the p-value, observed significance level or the p-value. So this one now, state your decision using the p-value is exactly the same thing. So if alpha level is bigger than this value, then this part, reject H0 and accept HA. Otherwise, there's not enough evidence to reject H0 and accept HA. All right. So in other words, you go and the new drug is better than the old. If this is the case, otherwise you cannot say that. Okay. All right. The third example, this one. So that one was that this two-tail test. So there were two rejection regions. We split our alpha into two. Remember that? This is alpha, the part A, 0.05, we split into two half. So the same way now, so in other words, there are two rejection regions, two-tail test. So once we get that, when you figure out the cutoff, you kind of need to work backward now. 2 points. So once you set your cutoff right on this value, so there's another cutoff on the other side you are setting because it's a two-tailed test. Alright? So in other words, when you try to figure out the p-value, so you need to figure out this both shaded areas. Okay? Either that z-curve value is less than this minus value or more than that. In other words, since this is symmetric around 0, so this is going to be 2 times that. So from the z-table, figure out this. That is going to be 0.0076. So as far as the part C, how you make the decision is exactly the same. If the alpha level is bigger than this value, which is the p-value, so then the same way, you reject the null hypothesis and accept the alternative. Otherwise, there's not enough evidence to reject H naught. Okay? So in other words, if the alpha level is bigger than that, the machine is out of control. So again, so this way, in the question, you don't need to have the alpha level. Always you can make your conclusion in this way. All right? So anyway, like say for example, if you are using any kind of software, statistical software, okay, so either R or the S or the SAS or whatever that, one of those softwares, so those things in general give you the p-value once you put the data in. And when you run the program, give you the p-value. So so then you need to make your conclusion by comparing that p-value with the given alpha level in the question. Or you need to, if the alpha level is not given in the question, you need to make your decision like that. All right? So so that's this p-value part. So the next part, actually I need to do one more example. So let me do that example in the next slide. And then I will get into the small samples. Okay, in the next video, okay, those details.